Hello, everybody. It's just after 4, so I'll wait a couple minutes to see if anybody else joins. Let's see how many we got at the moment. Oh, yep. 2, 3, 4, 5. That's good. Can everybody hear me okay? If somebody could just put in the chat if you can or can't hear me, that would be very helpful. Cool, thank you. A few props here, just to get ready. Wait one more minute before we kick off. Right. Okay, I think we'll start. So welcome to the webinar. My name is Gareth from DPA. And this webinar is all about the Helios and about it being CEC approved. So for those of you who don't know, Helios is a 16 kilowatt hour battery from Discover, and it was not on the CEC list until just the other day. And so not being on the CEC list, it was not eligible for the new battery rebate. But now that it is, that's very exciting because it's a perfect fit for the battery rebate, because it's a great product. It's really easy to install. It's at a really good price point, and it's perfect for on-grid applications. You know, the form factor for going down the side of the house, but it's also great for off-grid things as well. So let's just get into it. So in terms of the specs of the battery, it's a 48-volt battery, nominal. It's a lithium ferrophosphate battery. It's 16 kilowatt hours, and it's 16 kilowatt hours usable as well. It's IP65 rated, but as I'll explain in a moment, it's currently only CEC approved for indoor use, even though it has an IP65 rating. And that is not really to do with the actual physical construction of the battery. It's just a compliance issue with CEC, just to do with a label. And I'll explain a little bit about that, but we're going to get that sorted out as soon as we can. But at the moment, it's not so much of an issue because we've got nearly all of the current stock sold, and people aren't putting any of those outside, so it doesn't really matter in the short term. Its continuous power is 10 kilowatts. Continuous discharge, it says 200 amps here. It's a little bit lower than that, and you don't want to be, from a design point of view, you don't want to be running it at that continuously anyway, because you're going to use the capacity of it in an hour, an hour and a half anyway. The peak power is, it says 26 kilowatts here, but I think it'd be more like 15 for the surge. Not sure where this 26 came from, but again, sort of a common sense thing for a battery of this size. The peak current is 300 amps for 15 seconds, and so you don't really want to be going above that, and that would pair it pretty well with like an 8 kilowatt inverter. You could use a 10, but it would be the surge. If it was a 10 Noark, it doesn't have much of a surge on it, that would be okay. But if you're looking at like a Victron 10 kilowatt, the surge might be getting a bit high for it. It would work some of the time, but I would, in terms of your design, I probably wouldn't be designing it to be right on the edge like that. You can have up to 36 modules in parallel with closed loop communication. So you can have more than 36 modules, but the comms which links the batteries together has a limit of 36 for them all to be talking to each other, which is a pretty big system. The lifetime energy throughput is 94 megawatt hours. It's got a 10-year warranty and an energy performance warranty. Indoor and outdoor installation, it says here. It has self-heating, so it will, when the battery temperature gets down to a certain point, it will heat it and maintain it at a certain temperature. And it has dual fire arresters in it as well. Just on this point about, at the top here, about the kilowatt hour rating, this is something I get asked about with the sales staff quite often. And I had somebody ask me, a customer asked me about it this morning as well, about the depth of discharge and how that relates to how you'd actually set the inverter up. So the analogy I used with someone today is that imagine, you know, your car has a 50-litre tank. You can take all of the petrol out of the tank of your car and nothing will happen to the tank. There's no fault of the tank. You can use all 50 litres of the petrol, but that's not a good idea in terms of running your car. And so it's the same with, you have these batteries that advertise 100% depth of discharge, but that might be fine as far as the battery is concerned, but it's a terrible idea to set your depth of discharge to be 0%. It's going to cause all sorts of problems. So you shouldn't be ever designing a system expecting to use 100% depth of discharge on the battery. You know, that's just poor system design. 10% would be the very lowest I would go, probably more like 15, because all sorts of bad things happen when you take it down really, really low. And as soon as you start having multiple batteries, then taking them all down really low just increases the chances of other weird stuff happening when they're in that bottom state of charge. The self-heating, the manual talks about how the self-heating works in there, and the way it's described is a little bit confusing. It says that it won't allow you to charge it when it's below a certain temperature. But that's because you can't charge cold cells. And it says that it won't, what does it say? It says that it won't heat it if it's above 50% state of charge. And that's because you can discharge it when it is cold, you just can't charge it when it's cold. So you don't need to heat it when it's above 50% state of charge, because you've still got plenty of discharge. You only need to heat the battery up if you need to put some charge into it. So if you read that in the manual and it sounds a bit funny, that's the reason for it. It actually makes perfect sense, but the way they word it is slightly confusing. Does everybody understand that? What temp is cold? Negative 15 is too cold to discharge, and I think it's below 5 is too cold to charge. So, but in practice, the thermal mass of these batteries, now, you know, most batteries in Australia, you're very unlikely to get below 5, even if the ambient temperature is down there. The actual thermal mass of the battery isn't going to get there very easily at all. So it's not a problem that we see very often at all. These are Canadian batteries, so they're in a different environment. Well, they're designed in Canada. And so they get used in those alpine conditions where they really need this stuff. But here, there's very few applications where that's going to be an issue. And use your common sense, I suppose. If you are in a cold place, put it somewhere where it's going to have a little bit of protection from that, if you can. But again, the heating element of these means it's not so much of an issue. So it is on the CEC list. If you look it up on the CEC list, you will find it. It's this bottom one here. It comes in with the model number 900-0077. you can see that its usable capacity is 16.08, and currently it's not rated for outdoor use. It doesn't say Helios anywhere here, because I guess that's not part of its official name. And it's got the DC power rating as well, which is the continuous rating. The reason it's not allowed to be used outside, it is allowed to be used outside, but you won't get the battery rebate for using it outside, is to do with this label here. So I could go into lots of details about the compliance issues from the CEC, but basically this label is made by, when you make a battery like this and go through the testing criteria, you don't go and make your own label and test it. You buy it from a company that makes labels that are tested to international standards. And so this is an off-the-shelf tested label that is made, and then the company that does the certifying, called TUV, just accepts labels from that company that makes things to X standard and has been accredited to do so. And that normally works, but with the CEC best practice guide, they've got some extra clauses in here about it being mounted on a cylinder in ultraviolet light and tested for a certain number of days and a certain number of samples, which I think references a different standard. And so they just need to get this piece of paper saying that it meets that standard as well. So it's all pretty dry and pretty boring, but it's the only reason I'm really mentioning it is that it's not that they think there's a problem with the design of it or the IP rating of it or anything like that. It's just that they have a very narrow definition of what is required for the label, so that the label doesn't discolor or fall off or something like that. And it's been designed to this standard instead of that standard. And it's just a paperwork thing. So we're hoping to get that cleared up as soon as possible. Do some questions. If doing a ground mount against the wall, is there any adjustability with the feet for uneven ground? No, I don't think so. But it has a wall bracket. So the way it works is you put the bracket on the wall. Let's go to our next slide. You should be able to see that. It's a bit further on. There is a bracket that you mount on the wall. You lift it up onto the bracket, and then the rubber feet are just sort of taking the weight of it, and the bracket's holding it to the wall. So if it's uneven ground, you're just going to have to shim it, I suppose. It doesn't have those screw type ones. There is a question here, 16 kilowatt hours usable. So yes, you can claim, that's the reason I was showing it on the CEC listing, is that means that you can claim all of the STCs for the rebate for the usable capacity. When can we expect drop-down comms with SP Pro? Very soon. I've done all the testing for that and I've sent them the data. I just need to do some chasing up with them to get them into the next edition of the Wizard. They're all happy with it. I spoke to Ken Scott and he even came and had a look at it quite a while ago. So I think they've just got a bit of a backlog. I know that Power Plus are waiting on one as well. But I'll be doing an integration guide for that. And the settings are the same as the rack mount battery. So basically, you can use the rack mount battery in the Wizard, and then there's just a couple of settings that you need to change. Obviously, the amp hour capacity and the charge and discharge rates, but everything else about it is the same. All the voltages and stuff are the same. But I'll go through that in a little bit in a moment. So it's approved for on-grid and off-grid, of course, because it's a battery rather than an inverter. You can use it for either. The definitions of on-grid and off-grid are basically to do with the distance of the property from the grid, or the amount that it's going to cost to connect to the grid. And this is really only an issue for inverters that don't have VPP capability as something that they advertise. And the only one that we sell that doesn't have that is Victron. which is ironic because Victron has the most flexible comms of all of the inverters, but they haven't got an active integration with a VPP partner at the moment, even though they very easily could with an API or Modbus TCP. So it's only really an issue for that. Everything else, if you're using a VPP-ready inverter, it wouldn't make a difference. Electronic is VPP-ready with their new comms box, the UBI. So compatible inverters: Victron, Electronic, Noark or Day, Solus. Over here, you can see there's a full list which is available from the Discover Setup Guide. It doesn't have an official compatibility with GoodWe, but basically anything that uses the PylonTech CAN bus protocol will work, because the inverter isn't looking at the battery and going, testing to see which battery it is. It's just being sent voltage, current, discharge rate, charge rate, temperature, and errors. So as long as it's being sent those in the correct format, then it will work. So I know one person has used it with GoodWe, but it's not a supported integration. But a power source is a power source. You can also run it open loop as well. So you could do that with SMA and things like that. But again, it's not an official integration with those. But all the ones that we sell, Victron, Electronic, Noark, and Day, it all is has a nice integration. We've got nice integration guides for all that stuff. In terms of the physical installation, in terms of meeting CEC requirements for the rebate, this is all just the stuff you're going to see in AS 5139 and the best practice guide. All the normal conditions apply as to where you can put the battery bank, and the clearances and things that you should all be familiar with in 5139. If you want to get into the details of that, there's a great video by Glenn Morris about how to interpret those standards. But there's nothing different with the Helios with that, other than the fact that it's a self-contained battery, so it doesn't need its own enclosure. And once we get that approval, it will be able to go outside as well. Here we have the dimensions. So it's 900 mil high, the width is 465, and the depth is 247. So it's really good for going down the side of a property. So for like residential in the city, it's a really great form factor for that. But also in a shed with a bunch of them along the wall is equally as good. You see here we've got the specs that I was talking about before. So we've got the capacity of 314 amp hours, and then the maximum discharge rate is 300 amps RMS, which gives you what your surge is going to be. So that's sort of another point I'd like to just hammer in a little bit about just your system design, is that you shouldn't really be designing things to be right on the edge. So if you shouldn't really be expecting to use that 300 amps surge, unless it's sort of like imagining for some sort of emergency scenario or something like that. You should have headroom for these things. You don't want to be operating anything right on the edge, because you're just inviting issues. And usually in those scenarios, the capacity of the battery wouldn't be well matched to a load like that anyway. So you're not normally going to get into that type of situation. Battery terminal on top left and right of battery. Can we daisy chain 3 batteries from terminal to terminal? Or is it best to use 3 sets of cable? So the issue with these is that they're designed by Americans. So they don't have the same rules that we do. It has an integrated 200 amp breaker, but it only breaks 1 pole. So you have to use an external 2-pole breaker for each battery. It's not too much of an issue, especially if you're just putting 1 battery in, because you need one for the inverter anyway. It's a bit of a shame because it has these great bus bars inside it, and you can see from this picture here, and hopefully I've got some better pictures. There we go. You've actually got 4 terminals on each side, and so they are designed to be daisy chained together. And the first samples we got came with these interlinking cables with it's not an Amphenol connector, but it's that style connector on each side to put them in parallel. But my reading of the standard, and I asked Glenn Morris about this, and he read it the same way that I did, is that each battery needs to have a 2-pole breaker. So you wouldn't be able to use those internal bus bars because you then wouldn't have a 2-pole breaker on each battery. But the reading of the standard, because that's seeing them as separate battery systems, you could read it that you put them all together and that is one battery system. But I don't believe that's a correct reading of the standard. But otherwise, that's what it's designed for. But our recommendation is to use 3 of these and then go up to your bus bar. I'll just share my screen here. And I've got some examples. Just check that everybody can see that. Can you see the schematic that I've just put up? Somebody could just say. No, is that not working? Let's have a look. Oh, no, oh, there we are. Okay. So can you see the schematic? Yeah, looks like you can. Okay, so if the inverter is less than 2 meters from the battery, you only need to use a single 2-pole breaker. And so that can cover the inverter and the battery. That's in the scenario where you have 1 battery and 1 inverter. Once you have 2 batteries, you're going to need to have a breaker on each battery. But if it was less than 2 meters away, you wouldn't need this inverter one, because your shutdown procedure can just be turn off this one and turn off that one. But if it was more than 2 meters away, you're going to have 1 on each breaker, go into your bus bar, and then another one into the inverter. There's lots of bus bars available, but the ones that I recommend are the Victron LYNK's power in. They work pretty well for this, and you can couple together as many as you want, up to 1,000 amps. So they're really handy for that. Got a couple of different diagrams here. This one here is wrong because it doesn't have a separate breaker for each inverter. Yeah, so we'll go back to here. Next to my presentation. So the chat there. So yeah, we've got all these connectors, but at the moment you're just going to be using a single pair or 2 pair if you wanted to double up the cable sizes. We've also got these COM ports on the side here as well. So COM1, COM2, COM3, and COM4. COM1 is USB-C, and that is just for connecting to your laptop. If you want to do some diagnostics on the inverter, you wouldn't be using that for general commissioning. COM2 is CAN bus, and so that's going to go straight from the battery to your Noark inverter, your Selectronic inverter, or your Victron servo. It's on comms. The CAN bus is on pins 4 and 5. So 5 and 6, sorry, which are the standard CAN bus pins. So when you're going into Noark, you can just use a straight RJ45 cable. When you're using Selectronic comes with a crossover cable, which is fine to go straight into the Helios. when you're using it with Victron, you're going to use a Type A cable from the Helios into the servo, just the same as Pylon Tech. Comms 3 and 4, there is two options. So if you're not using the link box, then you need to make sure that you put this into one of them. So it ships with this. This is an N terminator plug, and the LCD screen and the CAN bus profile won't boot properly if you don't put this in. If you have more than one battery, you're going to daisy chain your COM3 to COM4 on each battery to connect them all together. And you just need one of these in one of the batteries, the first or the end. Otherwise, it won't work properly. We haven't had anybody lose this yet, but a couple of people have come pretty close. So just be careful when you unbox it to keep an eye on where this goes. If you're using the LYNK II, you don't need this because this does the end termination. And with the normal Discover rack mount batteries, you have to have a LYNK II. The rack mount batteries daisy chain together their comms, and then they go into here, and then the CAN bus comes out of here into the inverter or the servo. On the Helios has CAN bus built in, so you don't need to use one of these, but you can use it if you would like to. You could use the CAN bus out of it if you wanted to. It works just the same. But it also, if you want to use the LYNK Cloud, and I'll show you a bit further on about the LYNK Cloud, then you need to use this. So this would connect to comms 3 or 4, either of the bottom two COM ports, and then you would connect a Ethernet cable to your router, and then that would put it onto the LYNK Cloud network, and you'd be able to do remote monitoring, which I'll show you in a little bit. Would it support CAN bus to SP Pro and simultaneously use another comms port to connect to an EARL or Victron MPPT? Not sure what EARL is, but the problem with that is that you're splitting the CAN bus. But I suppose what you could do, I have thought about this a bit before, because you got CAN bus out of the Helios, you could then have this, and this would have a separate CAN bus to go to the servo, which would then control the MPPT. So you could do that. Oh, AERL, I see. But I think it would probably be missing the point a little bit, because it's broadcasting its maximum charge voltage, which is good. So both of them would get that, but it's broadcasting its maximum current as well. And so the inverter and the MPPT, the SP Pro and the MPPT, don't know what each other are putting in there. So they're not going to throttle their current properly. I mean, it's going to see the current that the battery is receiving, and so it might adjust itself, but it's not the way the system is designed. So you would be better to use the workaround which Selectronic actually have buried deep in their tech notes. It's for like a Morningstar or something, where you have a shunt, and the MPPT runs through a shunt which is connected to the SP Pro, and then it can see the current going in and adjust based on that. And we normally recommend that you set the charge voltage of the MPPT like a volt lower, just so that the AC coupled does the final stage. Or you could do it the other way around. But yeah, you could do it, but I would experiment with it and just see how it behaves. But I'm not quite sure the purpose of it, really. Yeah, I think it'd just be another point of failure, to be honest. Moving along, it has an LCD screen on the side here. They're actually getting rid of this because it's another point of failure, and it's unnecessary. Some people do quite like it because it's the only, you can see what the battery voltage is, because hardly anything's got a screen on it anymore. But it won't be included in the future ones. But the stock we have and the next lot of stock we have will still have it. And that just gives you some icons of faults, state of charge, current rating, voltage, all the normal stuff. if you turn it on and you're getting 999, that means you haven't put this thing in. All this is just an end of line resistor. So it's 180 ohms, I think. So if you do lose it, you can make one by just putting in a Cat5 cable and then putting those two that pair through a resistor to terminate it. But it's going to be messy. But it's the same as the Schneider one, which you can buy from like DigiKey or something like that. I'm getting spares. I'm just not sure when they're arriving. But the Schneider one is like $20 or something, which is silly for what it is, but not too bad. Moving along, this is just an example of how you mount it to the wall. It's a 2-man lift because it's 140 kilos. We recommend that you get one of those winching trolleys. But I do know one of our installers does them by himself, and he just gets, I think it's 2 star pickets or something, and he levers it up so he can get it on the bracket. So you can do it by yourself. And while it's on the skid, because it comes on a skid, and this nice sort of compressed cardboard, I can actually move around the factory floor by myself, even though it weighs twice what I do. So it's actually pretty maneuverable when it's on the skid. Got a BYD LVS connected to USB Pro with a Victron MPPT via the shunt, and the BYD keeps spitting out alerts and had to reduce the Victron by 2 volts. Yeah. Yeah, I'm not sure. I'm not so familiar with the BYD LVS. I guess it depends what alerts. Are they high voltage alerts? Yeah. So you can do open loop configuration. You can see I've got the wrong picture of wrong batteries here. And that's just when there's going to be no comms between the battery and the inverter. And it means you're just going to have to rely on the inverter reading the charge voltage and the current. Nothing wrong with open loop. In some situations, people might prefer it. That's one of the reasons Power Plus, I think, were really popular, is when lithium batteries first came along, they all had comms and the comms didn't work very well and everyone had a terrible time. And then Power Plus came along without comms and people were a lot more comfortable with that. With Cellectronic, Noark, and Victron, they can all revert to open loop if the comms fail, but they all sort of do it slightly differently. So with Cellectronic, if you use the wizard, you're going to set up all the charge voltages and all of that stuff as if it's open loop anyway when you set them up, and then the CAN bus basically takes over. So if it loses comms, it's got all the settings and it knows what to do. But when it loses comms, the Cellectronic will shut down, and you have to turn the inverter off and turn it back on again. And if it boots up without seeing any CAN bus, then it will just run as open loop. That's the only way to do it. As soon as you put that CAN bus cable in, once you take it out again, it's then going to turn off and won't do anything until you reboot it. For Victron, it will do something similar, but you can go in and restart the V bus, and you can go into the MPPT, and it will be in external control, and you can take it out of external control to get it to all start operating again. So you can do that through the VRM portal, as long as you've still got access. A lot of the time, though, if you've lost 240, then you'll lose your internet access. But you could set up your router and that to be powered off the DC bus if you want to, with a 48 to 12 volt converter or something like that. With Noark, you're going to have to go and change the settings to voltage mode for it to operate. And you could do that remotely, I think. Yeah, you can. As long as you'd still have comms. So again, the same issue about powering the router. Closed loop. So battery communicates with inverter. Inverter charger gets battery voltage current directly from the battery. The battery can tell the inverter to stop charging. That's the advantage of closed loop. Basically what that means is that when you have open loop, you have to have settings which fit all scenarios, which typically means that the charge current is slightly lower. Whereas when you have comms, you can have dynamic charging. So that means that you can charge it at a higher rate, sort of in the middle of the charge rate, and then throttle that back for the end of the charge rate when it wants to balance and things like that. So it typically means you can charge it faster than you could open loop. It's one of the main advantages, other than just getting the information about the battery's health straight from the horse's mouth, is the other great advantage of comms. Particularly with the Discover USB connection or with the online portal, you can see much more information than you normally would. So here's just another example of where all these COM ports I was talking about. And so it's just a really easy mistake to make. So the CAN bus port is this one on the top right. It's an RJ45. It's the top RJ45 connection. That's the one that goes to your inverter or your servo. The bottom two are for either connecting multiple batteries in parallel or for connecting to this. So they're not CAN bus, they are LYNK bus. You can see it says LYNK port on there. You can't see that very well. And if you're not connecting to that, then you have to have this into one of them. Here's a nice little diagram of that. So you can either go straight to the inverter, or you can go straight to the inverter and with the LYNK II. And the LYNK II connects to your router for internet access. It's a good idea to have the remote monitoring when you've got multiple batteries. And that's because what you get on the CAN bus is the aggregate value of all of the batteries. You're going to get the average state of charge. The voltage should be the same on all the batteries, because as soon as they're connected together, as long as there's no resistance in the cable, then the voltage should be the same. But you're going to get the current flow of all of the batteries rather than being able to see what current flow each battery is receiving, and of course the state of charge. So when you've got one battery, the information you get over the CAN bus will be pretty much the same as what you see in the cloud. Maybe a few less stats, but most of it's going to be the same. But as soon as you have two, the cloud, the Noark cloud or the Victron cloud is seeing aggregate data. But on the LYNK portal, you'll be able to see each individual battery. "36 batteries in total you could see on the LYNK cloud. Any impact to the warranty running open loop? No, there's no impact to the warranty for that. Now, I do have a little video here, but this new web platform I have doesn't show you that, unfortunately. It doesn't seem to work. But the video was just showing you basically how to take this apart and set up the CAN bus pinouts. But that's only necessary if you're going to use the CAN bus output of this, which you don't need to do with a Helios. With a rack mount, you have to use the CAN bus out of this, but the Helios has its own CAN bus, so you don't really need to use it. You're just using this to talk to the internet. I hope I haven't confused things too much by saying that. Again, laying on really thick about having this end terminator in. If you're using this, you don't have to have it. If you're not using that, then you have to put that in. On the Noark, the CAN bus port is inside the inverter here, in this spot. And you can see that you've got the pinout from the Helios, which is 4 and 5. I did have that right before. And then you've got the Noark is on 4 and 5 as well. Now, I said you could use a straight cable before, but on some of the models of the Noark, not all of them, you actually have to remove pin 6 because you shouldn't be sending the ground through. And the reason for that is that the ground on some of them is the ground for RS485. So the RJ45 plug on the Noark inverters actually is only using one pair for the CAN bus, and it's got another 2 pairs are used for RS485 communications for Modbus. So you can actually split it out and use it for different things. And it can cause issues if you have that ground from the Helios onto the RS485 ground. I haven't seen it be an issue many times though, but it's just something to be aware of if you have problems. Obviously, it's going to be set to lithium if you're doing closed loop with Noark. And then you're going to have set the maximum charge ratings and the battery capacity. The maximum charge ratings that you set in here will also be, you have the maximum charge settings here, and you have the maximum charge that you're going to receive over the CAN bus, and the inverter is always going to be used the lowest value, right? So if the battery is saying you can charge me at 100 amps, but you set a maximum charge rate of 80 amps in here, then it's going to go 80. Whereas if you set the maximum charge rate in here as being 100, but the battery's saying only give me 50, then it will only do 50. It'll always take the lowest value. And the same with the voltages and things like that. We're running out of time, so I'm going to go through these pretty quickly. You're going to set up your low disconnection voltage, state of charge, and reconnection state of charge as per normal in here. And like I said before, don't go below 10%. It's just good system design. If you're running an open loop, then you've got to use these normal voltages as you would with any other open loop system. In the Noark, it's really important to have the BMS error stop switched on. That basically means that if it loses comms, it stops instead of keeping on doing whatever the last message was. So that's really important for these lithium batteries. The other thing I'll say about Noarks is most of the tech calls I have for Noark are one of two things. It's DRM, demand response mode. It comes with that default switch to be on, and you don't need it other than in Queensland for a certain DNSP. Everyone else doesn't use it, so you just turn that off. The inverter just won't turn on if you don't have that switched off. And the other thing is that there's an on button on the side of the inverter, and it's counterintuitive because the LCD display is on whether you've got the on button on or off. So you think that you've got the inverter on because the LCD display is lit up, but actually you need to press the silver button on the side. Skip through this because you're not going to be using these. Sorry, I should have taken these slides out. So for Victron, you're going to need to use a crossover cable because you've got pins 4 and 5 for the CAN bus on the Helios, and then for Victron, it's going to pins 7 and 8. You can make your own cable, and you can look up the guide from Victron on how to do that, but just buy the Type A cable, and then you're done. Makes things much easier. And again, same as before, you're going to go into the CAN bus port on the servo or the Acrano from COM2. Make sure you put the end terminator into the servo, and make sure you have the baud rate set to 500 as well. Selectronic is the same thing. The Selectronic comes with that crossover cable, and that's just going into pins 1 and 2 on the Selectronic. And I think it's the second one from the bottom that you plug it into there. There we are. And you can, as a quick way of setting it up for Helios until we've got on the next wizard, you can just use the rack mount settings just with a few adjustments. And I'm going to be putting those up on our website the next couple of days. You're just throttling back the current basically, because there's a lot of DC ripple in a Selectronic, so you've got to make sure that the current is a little bit lower because they use a magnetic breaker instead of a thermal breaker, so the magnetic breakers are quite sensitive to the DC ripple. Or if you're a glutton for punishment, you can go into Selectronic's long-winded menu and set all the settings by hand. So the LYNK Cloud well, any questions on that, let me know. We've noticed that the day data sheet says 40 amps pass through on the 6 kilowatt and 50 amps on the 8 kilowatt, but we're seeing them at trip at 35 and 45 respectively. So the data sheet is out. Can you define what you mean by trip with the pass through? So I'm assuming you're not talking about your input breakers. You're saying that the inverter is giving you an overcurrent alarm and you've got a load higher than that in the pass through, I suppose. If it's the case with day, it will be the same with Noark because they're the same. The only difference is the portal and that you get local support. The physical unit is the same, and that's the same with SolarArc, SunSync. All of these are the same actual hardware and firmware and everything. It's just the portal and the sort of soft stuff, which is the difference. So we go with Noark because they've got people here, so that makes all the warranty stuff and the support stuff much easier than everybody else is just parallel importing the day stuff, and then you have to go back to day China for support, which is just difficult. Even that we sell a few day models, but we buy them through Noark to get that backup as well. So we got the link access here. So this is what you see if you connect to the Link or the Helios with the USB-C connection locally. And you'll be able to see the state of charge and the voltage and all the stats of each battery individually. It's here that you can download really detailed data logs from the battery in a CSV format and see they sort of take a reading like 3 times a minute or something like that. And so you can see really detailed troubleshooting stuff. That's not available through the cloud yet, but you can do that on site. So it's always a good idea to bring your laptop and not to lose the cable that goes with it. So you can get that information. And then if you connect the LYNK II to the battery, and then you connect the LYNK II to the internet, then you can access LYNK Cloud. This doesn't have Wi-Fi in it yet. I'm not sure when that's coming, but at the moment, it's only a hardwired Ethernet port. So you'd have to go and get a Wi-Fi extender or something from Officeworks. You can get them for about $50, and you just plug it into that, and then you're fine. These are just examples of different arrangements with the LYNK connected to the cloud. So you can see here, this is what the LYNK Cloud looks like. You can have multiple systems. You can actually put them into little groups and things like that. You can see that 3 of these are offline and the one in green is online. And you can see that on the overview page here, you can see the state of charge. You can see any notifications that they've got. And then if you click through onto one of these systems, you can have an overview page here, which is the current and the voltage and the temperature and the state of charge over the entire bank. But what we're really interested in is detailed alarms. So it has an alarm page here, which will give you high and low voltage, state of charge, temperature, all of these alarms that can get sent to your email address for each individual battery. And you can set the trigger time as well. There's a bit of nuance there. And then we're just really interested in this battery list here, which tells you what's happening with each individual battery, the state of charge, the voltage, the throughput. So you can see charge and discharge kilowatt hours here. So you can see if one battery is working harder than the others. And that's going to give you an indication long before the customer has a problem that maybe something's not right. So the example being, you put a big bunch of batteries into a system and you're hoping that they're all at the same state of charge, but really to begin with, they're going to be all over the place. And you normally don't have visibility on that, but with the system, you can see if one of them is a different state of charge to the rest of them, which means it's going to possibly have an issue down the track, but you're going to be able to see that before it happens and you're going to be able to plan to go to site or look at it online and get some support before it actually fails and you've got a customer actually complaining to you. you'll be able to see that here in the portal. Here's an example of one with high voltage, and you can see which battery it is, and then you can see the rest of the stats there. And that's going to save you a lot of time, because instead of having to go to site, inspect the system, find out what's wrong, come back again, and then get your replacement BMS or whatever it is you need and go back to site, you're going to be able to diagnose the issue remotely. So it might be one site trip instead of two, which is a huge saving. Or it might be, a lot of the time it can be something that's fixed remotely. This is an example of what the download data looks like. You can see that the resolution is really, really high. So these files get really big really quickly, which is why they're not available through the portal yet. But this is really good for figuring out what's going on with the system if you need to. So that's it for the Helios, and then I'll quickly go over this Victron Android tablet thing. If there's any other questions. You need to test a Noark 6 kilowatt pool, it's 35 amps on the UPS, and it will trip when the data sheet says it's supposed to be 40. Okay, I will test that. I've done pretty big loads on the Noark we've got here, but I don't know if I did it with the pass-through. I only did it from the battery. Yeah. That's news to me, so thanks for that. So Victron have this relatively new feature, which is using a tablet as a remote display. So I have a Victron Easy Solar GX in the other room switched on. It's connected to the local area network, and this tablet is connected to that same local area network. And so I've got basically the servo screen here that I can navigate in the same way that I would with the GX Touch or the remote console. And it's pretty easy to set up. And I'll show you how to do that in a moment. There's a great guide from Victron, so I'll just show you just a high-level overview. This tablet I would not recommend using. You can use pretty much any Android tablet, but this tablet I got from Officeworks for $80, and the man in the store did tell me not to buy it and that it was rubbish. I explained that it was just for testing here in the office, and I was putting a new operating system on it. And it does work, but when the battery runs flat, I have to sort of do this hard reset on it every time to get it to turn back on again. I thought that it was totally cactus to begin with. So I wouldn't recommend getting like an under $100 Android tablet. I'd recommend getting something, and this is it's like a totally unknown brand. It's a laser, which I'd never heard of before. So don't use something diabolical, but an old one, a low speed old Android tablet you've got sitting around will be fine. Or just, $150 type tablet will be fine. And so all you do, you'll have to, if you have an old one, you'll have to reset it to factory defaults, because the way that you set it up is that when you first turn it on, you'll go to the screen, and instead of pressing start, you go down to this little button down the bottom, which allows you to scan a QR code, which is on the Victron website. And then that starts this alternative setup procedure. It will download its firmware from the internet. You'll go through a few stages that it will guide you through, and then you connect it to the user's local Wi-Fi, and then it will search. You can see here it will search for the servo on the network, and you tell it which one you want to connect to, and it will connect to it. So it's pretty quick and easy. These links here, there's a blog post from Victron, and then within that, there's a link to this manual which shows you how to do it. The link in the blog post is like tiny. This is at the end of a sentence. It's really easy to miss, but it is there. And that gives you detailed instructions, but the majority of it is just boot up from standard and scan this QR code, and then it just sort of guides you through it. It's pretty straightforward from there. Once you've finished installing it, you've got it operates pretty much the same, but you can have some extra settings. So by holding down this corner here, You see it's in that picture I've got there. I might have to go back to the main screen to do it. If you hold down this corner, it can be a bit finicky, and it will bring up this extra menu, which is like the tablet menu. There you go. And then you can select screen keep on, or have the screen turn off after X amount of time, auto rotate, show the battery status, check for updates. And this is where you can set the Wi-Fi settings, search for devices. So if we go search for devices, let's just see. Yeah, so you can see the servo that I've got on the network here. The angle's not very good, is it? Well, you can see it here in the slide as well. And you can also add it manually if you've got the IP address. I also got from Amazon this little sticky thing that goes on the back, and it comes with a mating part, which has 2 screw terminals you can put on the wall. So you just slide it in and rotate, and then it will just sit nicely on the wall like that. So the application that this has been used for with some of our customers is just when the system is going to be in a shed a long way from where the users are, and they don't want to look at it on their tablet because they're not, sorry, on their computer or something, because they're not particularly computer savvy, but they want to have an interface. And so you can set this up for them, and you can still have the GX Touch in the garage if you want to, but you can set this up for them, and then they go at a display in the house. I'd recommend having it somewhere on the wall permanently with a USB power supply just to keep it alive, because you can't use the tablet for anything else. One scenario where the customer didn't even have internet or a router, so we actually helped the installer to put in a little mini router as well, which he connected to the servo, and then allowed this to connect to that over Wi-Fi. So if you need some help with that, just let me know. But it's a pretty good little feature, I think, and there hasn't been anything quite like it available in the past that sort of works as nicely. You do need to set up the servo to the latest firmware before you do all of this, otherwise it won't be able to find it on the network. So you need to set it up to the latest firmware, and you need to turn on remote console and all that normal stuff before you do this. And that's pretty much the end of my slides. Any questions about this remote tablet option? Nope. Or questions about the Helios? I think I covered everything with the Helios. There's more stock. Most of the stock we have at the moment is on its way out the door, but there's more coming in very, very soon. So you should be fine for jobs coming up. We're expecting a big rush with the rebate. Will Helios bring out a modified model with 2 pole breaker in future? No, I don't think they will. We push really hard for that, but it would have to be retested, which costs like $1 bazillion million. So yeah, I did have a red hot go at that. And because the way the BMS works is that the breaker that I have at the moment is on the positive, and the negative actually comes through 2 big contactors. So it is actually breaking the positive and the negative, but it's isolation on both, and it's overcurrent protection on both as well, but there's not a linked overcurrent protection. It's the BMS. So I did actually sort of try and make this argument, and I did ask Glenn Morris to help me make this argument to them, if you could sort of do it electromechanically, but they weren't into it, unfortunately. But you know, it's okay. It's better to have better to have standards that are too strict rather than too lax, I suppose. A graph voltage versus SOC. I mean, the graphs are the same for all lithium, right? There's lithium ferrophosphate. I don't know if there's a specific one for Helios. I'll check the manual. But in general, all these companies are, they call them battery companies, but they're really BMS companies, right? because they don't make the cells. The cells come out of these massive factories in China. The most battery companies, maybe BYD is a bit different, but most of them aren't vertically integrated, making their own cells. So the voltage to SOC chart is going to be the same for most lithium ferrophosphate. But remember that the way that a lithium cell works is, the BMS doesn't have some magic access to some other information to tell you what the state of charge of the cell is. It's really just operating the same as like a Victron smart shunt does. It's just measuring coulombs in and coulombs out, just amps in and amps out, and it's just saying, when I get to a certain voltage, I'm going to call that 100%, and then it counts back down and up from there. There's no other metric that it's using to determine state of charge. So any sort of lithium ferrophosphate chart is going to be the same as another, really. But it's not like somebody else has said, it's not a particularly reliable way of determining the state of charge, because it's such a flat profile. Even with lead acid, it's not really very reliable. We're doing some experiments at the moment with sodium batteries. So that's not saltwater batteries like those old Aqueon ones, but these are sodium ferrophosphate batteries. So pretty much the same chemistry, but replace the lithium with a sodium. And they operate quite differently because you can take a lot more of the charge out of the battery before the actual plate falls to pieces. And so even though they're a lot less energy dense, they can achieve a similar battery footprint because you can actually discharge them much, much lower than a lithium. A lithium, you can't take much out of it before the plate falls to pieces, whereas sodium, you can take a lot more out of it. But it means that the voltage range is massive. The voltage range is sort of 45-degree angle. So with something like that, that sort of curve would be quite useful for determining state of charge, but the lithium ferrophosphate is not very useful. 52 at 40%, 51.9 at 60%. Yeah, where did you read that? Sodium bottom 25% unusable, voltage goes too low. It depends. So if you're using high voltage, then the high voltage inverters already have these massive voltage ranges, because they're used to having maybe 4 in series or 6 in series. So they have this massive window. So the sodium batteries will work quite well for that. They'll be useless for things like forklifts, because as the battery gets to 50% state of charge, it's got half of the voltage or something, and so you're going to have half the torque. But anything that's using power conversion equipment to take that into something else, then they'll be good, and they're much safer, supposedly. So they'll be useful in applications where people don't want to put lithium in. And sodium is much more abundant than lithium, and apparently there's a lithium shortage coming. So sodium won't have that problem. But the inverter manufacturers will adjust as well, because it's only the bottom of the range that is a problem for the inverters. The top of the range, the inverters could actually go higher because they don't need more FETs. They don't need more FETs, so they can switch more, because the current is going to get lower as they get towards the top. It's just the voltage rating, the components like the capacitors and FETs, that stops them from going higher, and they haven't needed to. So they could actually extend their range probably pretty easily. Probably just a software thing with some of them. I already spoke to Selectronic, thought they might be able to go up a fair bit. But you might need to have like a 17 or 18 cell sodium battery instead of a 16. But I've got one here, which is a 48 volt nominal one, and that worked fine in the day range. I got the full capacity out of it, but I think that's because they called it a 50, but actually it must be more like a 75 or an 80. But you can't use that capacity, so they've matched the advertised specs to the voltage range of the inverter, I think is what it is. So we're over time, so got to finish up. Any last minute comments or questions? No, okay. I will send out the slides as well, and it will be available on YouTube shortly, and there will be a link pretty much within a day or something to sort of kick me out for a moment. But yeah, this is the end anyway. So thanks for coming, and any questions, just send us an email and we'll get back to you. Thank you.